Hello, everybody. I wanted to talk more about what we ended class with yesterday about talking about the relationship between type 1 error, your significance level alpha, power, and type 2 error, which we call beta. I made an incorrect statement when I said that power was inversely related to alpha and type 1 error. Power is actually directly related. If you notice in the picture here, we have them on the same side of this line. This line represents our sample hypothesis and how far away it is from our alternative hypothesis. And this little graph below kind of represents the true proportion. This P is the true proportion. The closer the true proportion is to the hypothesized proportion, the less likely you are to reject. And so that changes your alpha. Remember, alpha is the probability of type 1 error. It's because that's the percentage of the time you would reject. If it's 0.05, we're going to reject if the probability is less than 0.05. So the type 1 error is, the probability of that is 0.05. And as we increase our alpha this way, increasing alpha would be going this way. So we went from 0.5 to 0.1, that area under the curve is getting bigger. So alpha gets bigger, type 1 error gets bigger. And if you notice, this area would also get bigger. The power area would get bigger. But the area for the beta, the type 2 error, gets smaller. So type 2 error is inversely related with the type 1 alpha and power. So I have it written here. Alpha significance level, type 1 error. Alpha is the significance level, so you have to know those by both names. And the power are directly related. That means as one goes up, the rest go up. And if one goes down, the rest go down, right? If one is decreased, they all decrease. If one is decreased, would actually be this way. If I increase one, I increase all the rest of them. But the type 2 error is what's on this side. So as I increase the power, I am decreasing type 1 error, but that increases type 2 error. And if I increase or decrease the power, I'm increasing the type 2 error. So we have to understand that relationship. And there's only one way to actually decrease both types of error at the same time because they're inversely related. If I increase alpha, I decrease beta. If I increase type 1 error, I decrease type 2 error. If I increase type 2 error, then type 1 error decreases. I can't have them both decreasing at the same time unless I increase my sample size. If I increase my sample size, my models get narrower because the standard deviation gets smaller and both of those areas shrink. I'm going to type that in here for you. Okay, so to decrease both type 1 and type 2 error, we would have to increase the sample size. Let's see, how did that? To increase the sample size. Okay, so that's the information I want you to have about that. And then, since I'm not going to be here for the rest of the week, I wanted to go over some examples from kind of homework problems and how you would word your responses when you're talking about type 1 and type 2 error. And hopefully you watch this before you try to do tonight's homework. Okay, so here's an example of one of the problems you might be asked to do in tonight's homework. This is number 2020 from the book. It's about Alzheimer's. Testing for Alzheimer's disease can be a long and expensive process consisting of lengthy tests and medical diagnoses. Recently, a group of researchers devised a 7-minute test to serve as a quick screen for the disease for use in the general population of senior citizens. A patient who tested positive would then go through a more expensive battery of tests and medical diagnoses. The authors report a false positive rate of 4% and a false negative rate of 8%. Put in this context of a hypothesis test, what are the null and alternative hypotheses? So a lot of times with the chapter 21 questions, we're going to actually think about the hypotheses in sentences. So we have our null hypothesis would be that the senior citizen does not have Alzheimer's. Okay. And I apologize for the tapping. I couldn't find wired headphones at home. And then our alternative would be that the senior citizen has Alzheimer's. Okay, so that would be what we're testing. We don't know what the test actually requires, but we know that this is what they do, the quick screen, and if the test comes back with enough evidence, then we think the senior citizen has the Alzheimer's and they go have more tests. So what would a type 1 error mean? Okay, type 1. I always like to write out type 1 error as that we reject, but we are wrong. The null hypothesis is true. That's the general idea of a type 1 error. Now you have to put it into context of this problem, right? So the senior citizen is given extra testing because the initial screening concluded he, she, they has Alzheimer's. But they were wrong, or it was wrong. The initial this initial test was wrong. The person does not have it. So we rejected the null hypothesis that they did not have Alzheimer's. We thought they would, that they did, so we sent them on to get more testing. And then after the extra testing, it was concluded that they don't have it. So the initial test was wrong. That's type 1 error. C, type 2 error, is failed to reject. But we are wrong. HO is false. So the initial test says the senior citizen does not have it. And they're not sent for more testing. But it was wrong. The senior does have it. Okay. It's important to reread your sentences to make sure that they make sense. These can get really kind of confusing, and a lot of times we say like this is true, but then this is true, and we need to mention that we made a mistake. We were wrong. There was an error, and that helps the sentences to make more sense. So which is worse here, a type 1 or type 2 error? I would say in this case, a type 2 error would be worse because the person who has Alzheimer's is not diagnosed with it. And so they go about their business and they keep getting worse, but they're not getting treatment because they had this test that said, no, you don't have it. Type 1 error would be, oh, you're sent for extra testing, but oh, look, you don't actually have it. Yay, that would be a good experience, but it would be bad for someone to be tested and told they don't have it when they actually do. So that would be which one is worse. And the power of the test, the power is the ability to correctly identify senior citizens with Alzheimer's. So it's correctly rejecting the false hypothesis, which is correctly finding people that have Alzheimer's. Okay, so this is kind of what the questions are going to be looking like in chapter 21. You'll have to identify and be able to write that out. Here is an AP exam question that deals specifically with types of error. This is from 2003. It was number 2. When a law firm represents a group of people in a class action lawsuit and wins that lawsuit, the firm receives a percentage of the group's monetary settlement. That settlement amount is based on the total number of people in the group. The larger the group and the larger the settlement, the more money the firm will receive. A law firm is trying to decide whether to represent car owners in a class action lawsuit against the manufacturer of a certain make and model for a particular defect. If 5% or less of the cars of this make and model have the defect, the firm will not recover its expenses. Therefore, the firm will handle the lawsuit only if it's convinced that more than 5% of the cars of this make and model have the defect. The firm plans to take a random sample of 1,000 people who bought this car and ask them if they experienced this defect in their cars. Define the parameter of interest and state the null and alternative hypotheses that the law firm should test. So, the parameter of interest is, what are we trying to figure out? We're trying to figure out the proportion of cars that have the defect. So the parameter is the proportion of cars that have the defect. The null hypothesis would be the proportion of cars, that's P. Okay, this is going to be P naught, is 5%, 0.05. Because it says here, if 5% or less of the cars have the make and model, the firm will not recover its expenses. If more than 5% of the cars of this make and model have the defect, they will handle the lawsuit. So our alternative hypothesis is, what does it need to be to handle the lawsuit? It's greater than. They're only going to handle the lawsuit if it's greater than 0.05. Okay. So that is part A. Write your hypotheses, and then in context of this situation, describe type 1 and 2 error and describe the consequence of each of these for the law firm. So again, type 1 error, and it's important we identify these correctly. Type 1 is reject, but HO is true. Okay, so the company does not believe the proportion is 0.05. They believe it's higher. So they take the case. But they are wrong. And the proportion is 0.05 or less. Okay, so they don't believe it's 0.05. They think, okay, we got a good proportion. It's higher than 0.05. We're going to take this case, but we're wrong. And the proportion is actually 0.05 or less. And so what happens there is they do not recover their expenses. So the consequence takes the case and does not recover their expenses. Type 2 error is fail to reject, but HO is false. So the company believes the proportion of cars with the defect is not greater than 0.05, so they don't take the case. But they are wrong. And P is greater than 0.05. Consequence is they lose out because they don't take the case, but they would have won. If it's greater than 0.05, they would have won, so they miss out on making a lot of money. You can see how this idea of hypothesis testing and error comes into play in all different kinds of fields.